मेरे प्यारे बच्चों, आज हम फिर बात करेंगे चैप्टर सेंटर ऑफ मास एंड रोटेशनल मोशन से रिलेटेड कुछ टॉपिक्स के बारे में, जैसे कि सेंटर ऑफ मास ऑफ अ सिस्टम ऑफ एन पार्टिकल्स। ऐसा सिस्टम जिसमें एन पार्टिकल्स हैं, उसका हमें क्या पता करना, सेंटर ऑफ मास। The resultant obtained in the previous article are generalized easily to a system of n particles not necessarily lying in a plane but distributed in space. If vector Ri be the position vector of ith particle and Mi be the mass of the ith particle, then generalizing equation, the position vector R of the center of mass would be given as vector R is equal to sigma I is equal to 1 2 I is equal to n mi Ri vector upon sigma I is equal to 1 2 I is equal to n mi. The single sigma, the Greek letter sigma, denotes summation in this case over n particles. The index I runs from 1 to n. The sum sigma I is equal to 1 to I to n mi is equal to m is the total mass of the system of n particles. Therefore, from equation vector R is equal to sigma I is equal to 1 to I is equal to n mi Ri vector upon m. तो इसको करते हैं, if Ri vector be the position vector of ith particle and mi be the mass of the ith particle. Then generalizing equation, the position vector R of the center of mass of the center of mass would be given as vector R is equal to sigma I is equal to 1 to I is equal to n mi vector Ri upon sigma I is equal to 1 to I is equal to n mi. The symbol sigma the Greek letter sigma denotes summation in this case over n particles the index I runs from 1 to n. The sum sigma I is equal to 1 to I is equal to n mi is equal to m is the total mass of the system of n particles. Therefore, from equation vector r is equal to sigma I is equal to 1 to I is equal to n mi vector ri upon m. Equation first, equation second. Note that the sum on the right hand side is a vector sum. Let xi, yi, zi be the coordinates of the point where ith particle of the system is located. Therefore, vector r is equal to I cap xi plus j cap yi cap xgi. Note that the sum on the right hand side is a vector sum. Is a vector sum. Let xi, yi, zi be the coordinates coordinates of the point where ith particle of the system is located. Therefore, vector Ri is equal to I cap xi plus j cap yi plus k cap zi. Equation third. If x y z be the coordinates of the center of mass of the system, we may write vector R is equal to I cap x plus j cap y plus k cap z. From equation second, I cap x plus j cap y plus k cap z is equal to 1 upon m sigma I is equal to 1 I is equal to n mi I cap xi plus j cap yi plus k cap zi. Equating the x y z components on either side, we obtain x is equal to 1 upon m sigma I is equal to 1 to I is equal to n MI XI for y is equal to 1 upon m sigma I is equal to 1 y is equal to n mi y z is equal to 1 upon m sigma I is equal to 1 to I is equal to n mi zi 6 equation. The number of particles, atoms or molecules in a rigid body of finite size is so large that it is impossible to carry out the summations over individual particles at this equation. As the spacing of the particles is small, we can treat the body as a continuous distribution of mass. Let us subdivide the body into n small elements of mass delta m1, delta m2, delta mn. If the ith element of mass delta mi is located about the point x I, y I, z I, the coordinates of the center of mass are actually given by the number of particles particles atoms or molecules in a rigid body of finite size is so large that it is impossible to carry out the summations over over individual particles in the equation. Particles in the equations as the spacing of the particles is small, we can treat the the body as a continuous distribution, as a continuous distribution of mass. Let us subdivide the body into n small elements of masses. Delta m1 comma delta m2 delta mn if the ith element of mass delta mi is located about the point xi, yi, zi. The coordinates of the center of mass are approximately c monthly given by x is equal to 1 upon m sigma is equal to n delta mi xi. Equation 7. 1 upon m sigma I is equal to 1 to I is equal to n delta mi. Equation 8. Z 1 upon m sigma I is equal to 1 to I is equal to n delta mi zi. Equation 9. As we make n bigger and bigger n each and each delta mi smaller and smaller. These expressions become exact. In that case, we denote the the sums over I by integrals. Therefore, sigma delta mi x is equal to integration x dm equation 10th. इसी तरह से सिग्मा डेल्टा एम आई बाई आई इजिकल टू इंटीग्रेशन बाई डी एम इक्वेशन 11th. उसी तरह से सिग्मा डेल्टा एम आई जेड आई इंटीग्रेशन जेड डी एम इक्वेशन 12. The coordinates of the center of mass now are x is equal to 1 upon m integration x dm 13. Y is equal to 1 upon m integration y dm 14. Z is equal to 1 upon m integration z dm 15. The vector expression equivalent to the three scalar expression is vector r is equal to 1 upon m integration vector r dm. 16. If center mass lies at the origin of our coordinate system, then vector r x, y, z is equal to 0. Therefore, integration vector r dm is equal to 0, or vector x dm is equal to integration y dm is equal to integration z dm is equal to 0. 17.